All right, last slide or last time when we were doing notes, we left off on isotopes. And again, remember an isotope has the same number of protons, but a different number of neutrons. So it's the same element. The atoms are just a little heavier or lighter because remember a neutron has a mass of 1. So if you want to figure out the mass of the atom, you have to take the protons and the neutrons added together. Okay, so when you write up what they call the isotopic notation, what you do is you put the symbol of the element, and then you put the mass number on top, and you put the atomic number on the bottom. Now, if you're using your periodic table, you'll notice that a lot of elements don't have like a whole number. Their mass number, if it's, the protons being 1 and the neutrons being 1, when you add them together, it should be a whole number. But it's actually, that is a combination of all the isotopes, and every element has a couple. Some have like 7, some have 3, some have 2. But when you do the mass, it's actually a combination of what they call the relativity and times its mass. And I'm going to show you how to figure that out. But when you're writing it out, what you would do is, let's say you're doing iron. So you'd put Fe here for the symbol, and its atomic number is 26. That never changes, okay? But let's say we have 3 isotopes of iron. One weighs 56, one weighs 57, and one weighs 58. In other words, one has 27 neutrons, one has 28, one has 29, or whatever. So that's what the number would go up here. So you have, this number can change for your different isotopes, okay? Okay, so here's phosphorus 31. You'd write it out here, and that tells me its mass is 31. So I'd put 31 on top, and 15 is its atomic number. That goes on the bottom. So in this compound, I know that 15 is the number of protons, 15 is the number of electrons, and if I take 31 minus 15, I get 16. That's the number of neutrons. And that's how you write it out. Okay, I just said that, yeah. Subtract them and you get 16. Okay, so this is how you figure out the number of protons, electrons, and neutrons. Okay, this chart, again, chlorine, you guys can do this on your own, but again, if you look, we'll do the first one. Okay, if we have chlorine and we write it Cl and we have 37 on top and 17 on the bottom, this is the atomic number. So that is the number of protons. Okay, if you have 17 positive charges, you have 17 negative charges, so it's also the number of electrons. And then to get the number of neutrons, I'd go 37 minus 17, and that would give me 20. Okay, so you can practice on the other ones you want. It's on here for you. And again, when I'm done with these notes, I will put the PowerPoint without me yapping on it, and so then you can go through it and review it if you want, or if you miss some notes or whatever, it's all there. Okay, so I'll do this quick. Oh, now I went too quick. Okay, carbon-14 dating. Okay, they use that to date fossils and all that kind of stuff. And it's an isotope of carbon. Most carbon is carbon-12, but there is carbon-14. So I'm trying to figure out how many neutrons. I just go 14 minus 8. 14 minus 6 gives me 8. That's all you have to do to figure out the number of neutrons. Don't add them together. Don't assume this is the number of neutrons. You subtract the 2 to get the number of neutrons. Okay? And again, this is an isotopic problem. So what you do is, if you're going to solve it to find the mass, what you would do is you would take this number times its mass, and then the other one would be what, 49.3, and you'd multiply by the other one. But in this case, they just want to know protons, electrons, and neutrons. All right, 35 protons, 35 electrons. That's right there. If I subtract these two numbers, I'm going to get 44, and that's going to be my number of neutrons. So where is that at? Right here. Okay. Okay. That top number is the mass, so it's the number of protons and neutrons added together. Okay. What is the mass number of an atom if it has 30 protons? That would be its atomic number. So the mass number, you'd add these two together and you'd get 65. Okay. All right. So again, when you're doing the mass, it's really a small number. So they say AMUs. It's kind of a derived unit. So if I wanted to do a mass of carbon-12, 1 unit, I would weigh it out as 1 gram, even though there's no way I can measure out an atom. So they made its system AMU. This is what it actually equals. So, 23 zeros, 166. Well, again, because that's such a small scale and there's no way we have scales that would measure that, they kind of made up their system. They call it AMU, and we would convert it with grams. Okay. So atomic mass, they based it on carbon-12 because carbon-12 is one of the most common substances and it's found in all living things. Okay. But again, I'll show you how to figure out the isotopes here in a second. Okay. So let's say I want to find the mass, the atomic mass of carbon, and we're only basing it on 2 isotopes. It actually has 3, but you'll get the idea. Okay, so what you do to figure out the mass is you take the percentage, the abundance of it, and you multiply by its mass. So I would have to change this from a percent to a decimal, so I'd move it over 2, so I'd make 0.9897 times 12. That's what I got right here. And then I would take the abundance here again. Now this is 1.11. Remember I got to make this a decimal, so I got to move it over 2. So it's going to be 0.011, and then I'd multiply by this number. And then you just add them together. So now some people think, well, if there's 3, just take the average of the 2. No, because then you'd get 12.5, and that's not, you have to take into account the abundance. And most carbon is carbon-12. So this is the way you do it. You take the percent times its mass. And again, you got to move that decimal over 2. And you take this percent, 0.01 times 13, and then you just add those numbers together. Okay. All right. So here we have bromine. I would take, instead of 79, you use 78.92 times its percentage would be 0.507. You'd multiply those 2 numbers and add them together, or multiply those 2 numbers, sorry. And then I would take 0.4932 times 80.92, and I'd add those together. And there's one way to check to see if you're close. Look on the periodic table. Okay, if you added those together, you're actually going to get 79.92. Okay, if you look on the periodic table for bromine, it's really close to that number. So by looking on the periodic table, looking at the number on the very bottom, that's a way of double checking to see if you did it right. Okay, well, that's that. Okay, so again, I'm going to show you some more in the discussion of how to find the mass of isotopes. But again, you got to remember, you got to take all of them into consideration and how much. It's not just adding them together and multiplying, it's not the average. You have to take into account their abundance. Okay, so, and again, the easiest way to double check to see if you did it right, look on the periodic table. You should be close to that number that's listed below. It's on the very bottom. Okay. All right, so we're done with this chapter. Work on your isotope masses, and we'll talk to you in chapter 6.